Hello everyone, welcome to my channel. Today I have picked a problem which is similar to some problem that we solved earlier. Here the criteria is a bit changed. In this one, earlier we had to find the array. We were given an array and target, and we just had to find two elements which is adding up to the target that was given. In this one, it is explicitly mentioned that the input array is sorted. So whenever we encounter such problems where it is already given that the input array is sorted, in that case, the first thing that should come up in our mind is binary search. Also, let's read a bit about the problem. It is given that the array of integers that in which elements are already in non-decreasing order. Whenever it is given non-decreasing order, that is the same that it is in increasing order and it is sorted already. It is sorted in an increasing order manner. Also, it is given that we have to find two numbers which is adding up to the target. And here we have to notice that it is exactly there is one solution that exists. In that case, whenever it is given, we know that we have to come to a solution. There is the solution that is existing in the array. It means that there are already two numbers that are adding up to the target. So we don't have to worry about the case when the solution does not exist. So like the earlier I said that input array is sorted. In that case, the approach we are going to use is somewhat similar to binary search. Let's quickly move on to solving the problem. Here, I will try to first explain a bit about binary search. In when I'll use the algorithm of binary search, you will get to know about the idea of how the binary search works, and also I'm going to use two pointers. So these might sound as a buzzwords to you guys, but when I'll explain it will be quite easy. So first I'll write how it will work. First thing that I'm going to use two pointers. So we will be having a left pointer, and also we will be checking that the left pointer should not cross the right pointer. Not pointer, but left index. Here the left is the going to be the leftmost index, and right is going to be the rightmost index. And apart from that, sorry. So, in binary search, we first compute the mid. So, mid is nothing. Sorry, what I'm doing, let me readjust it a bit. Okay, yes. So, in this case, when we have to just compute the mid, and mid is nothing but left and right's half of left and right index, sum of left and right, and we do its half. So that's how we compute mid. And we simply check whether the element we are trying to find. So in the binary search, what happens that we are given an array and we are given a target that we have to find. We have to find the index where the target exists. So in this case, we have to find the index where this 11 exists in this array. So for that, we check simply if we start from left index, we start from right index, and then we check and we compute the mid. So simply we compute the half, and we check whether we are able to find it in the half. So array of mid, does it exist at the half, at the middle index? If at all it exists, then we simply return it. And what I'll be explaining later on what if we don't find it in the mid. So first let's try run this one, left index, right index, and then the mid. So the first in this algorithm, the binary search, here we are given an input array. So I have taken this input array and I have just written the index where the elements are existing. 0, 1, 2, 3, 4. Now, the leftmost index is going to be 0 and the rightmost index is going to be 4. So I'll quickly write it 0, 4, and then the mid is going to be half of it. So it's going to be 2. So it will quickly check whether my target exists. Are we able to see at, so it is going to be 2. So array of 2, the array of 2 is 10, which is not equal to our target 11. So in this case we are simply, now we cannot return mid because we haven't find our target. So we will check, here comes the catch, we will check. Now we know that but we know one thing for sure, that the middle index, the element it has, it is smaller than the target I am trying to find. So we know in the binary search what happens when we are unable to find the element at middle point. So we know for sure that the element is not existing at the left end, like before the mid. So what is happening here, that if the element we are trying to find is 11, so we know which is greater than 10. Since our input array is sorted, we know that the target, if it is smaller, the middle element is smaller than the target we are trying to find, then we will move on to the right side. We will completely ignore the left part of the array. Okay. So uh, so, um, uh, so in this case, what we will do, we will shift our left index to the middle. Okay, so we will shift our left index to the middle, and then we will compute this, and will now our updated array where we have to find the target is going to be this. So this is a very simple algorithm which I have explained right now. So what we have, and I'm simply going to code what I just said. I said that if my array of mid is smaller than the target I'm trying to find, so I'll simply shift my left index to the middle plus 1. I have shifted my left index to mid plus 1. Now my left index is 3, and I haven't done anything. I haven't updated my right index. So it is 4. So 4 plus 3 is going to be 7. And we know that when we divide it by 2, it is going to be an integer. So 3.5 is not going to be considered. It is going to be considered 3 only. So, and it will simply check if now my index, the element at index 3, which is my mid, so it will again come here, it will come here also. Suppose if we could not, if there is a case when we could not find any element, like suppose there was this case when we are trying to find 7, and the element we are trying to find 7, and at mid we found that the mid element is 10. In that case we would have shifted our right index, this right index, to at that point, because we know that we don't have to check, we don't have to look for the middle element which is already larger than the current element we are trying to find, which is 7. I hope I'm not going much fast. So in that case we are simply moving our right pointer. Let me know if I'm going a bit fast, then uh, I'll try to make it more simpler. So I'm simply going to shift our right index, and it will be mid minus 1. And in the end, if I am able to find, so in this case we know that we have the solution. If at all, if there is no exactly one solution, in that case we simply return nothing we have found. So here we know that at third index 11 exists, and the target we have to find is 11. So it will simply return 3. That is the index. So here we have used two pointer approach as well. Now we have you now I have explained two pointer as well, and binary search algorithm as well. You guys, I hope you guys might have gotten the idea how two pointer works and binary search works. Okay. Now using the similar approach and similar algorithm, I'm moving towards the solution that I'm going to find. Let me quickly remind the problem I was trying to solve. Here we are given the array 2, 7, 11, 15, and target I have to find 9. I simply have to find the index of two integers, two numbers, that is adding up to 9. 2, 7, 10, 15 is given, and I am going to use a similar approach, just a bit tweaked. Let me tweak it. So we don't have to find middle element, because what we are going to do using the 2 pointer, we will just check whether the array of left plus array of right is adding up to the target. Then we will simply return both of this index. Also, if you notice, we are asked to return not the index but the position. 0 and 1 is the correct index, but the position we are asked to return. So we will simply return the positions. Right now, it is going to be left plus 1 and right plus 1. And if my array of left and array of right, the sum is not adding up to the target, but it is less than the target, in that case, we will move our left pointer. We will move our left pointer, because if the target is lesser, if the target is greater, so here notice properly. If okay, I'll explain later. Let me do this first. And explain it how I'm going to do this. Now, in this one, my left is my right and my target. So we are first, my left index is 0 and right index is 3. Now, target is array of 0 is 2 and array of 3 is 15. So 2 plus 15 is 17. It is going to get compared. Array of left and array of right is going to get compared with the target. Is 17 equal to target? It is not equal to target, right? It is not equal to 9. Now, in this case, 2 plus 15 is not adding up to 9. We have to move. We know that we know one thing for sure, that our target is greater. Our target is greater than what we are trying to find. Sorry. In this case, our target is 9, and the number we are getting here is 17. So we know that our target is smaller than the number. Our target is smaller than the number, the sum that we are getting right now. So in that case, since we know that input array is sorted, we want to find an element which is smaller than the current index that I am working on. In this case, we have to move our right index to the left. So if the sum, now I'll complete the algorithm. If the sum we are getting right now with the left and right indexes is smaller than the target, then in that case we have to shift our left index so that we can achieve some higher number. And if our target is greater, if our target is greater, in that case we move the left element. And if our target is smaller, which is going at the end in the else part, in that case we will simply decrement our right pointer. So this is the third case we are encountering right now, that the target that we have right now, we are trying to achieve 9, but we are getting 17. In this case, we will simply decrement this right pointer, decrement this right index, and we will switch to second index. It will compare now what is at the second index. It is 11. So it will add 11 plus 2, 13, and 13, which is also not equals to 9. Again, the case will come when we have to shift our right pointer, and it is 13 is not equals to 9, so it will simply come to the first index, and at first index it will find 7. And at 7, if we see 0 and 1, it is 2 plus 7. And 2 plus 7 is 9. And now we have we have come to the case where our target is exactly what we are trying to our sum is exactly what we are trying to look for the target, and in this case these both positions are going to get returned. This is simply what I'm going to do in the code. I'm quickly taking up the last problem, and we will move on to the solution. I'll quickly write here this one. Numbers are given as this, and it is simply targeted 6. So the left pointer is left pointer is 0, and the element here is 2. Right index is 0 1 2 4, and the element here is, sorry, 0 1 2, index is 2 and the element here is 4. So clearly it can be seen that the 2 plus 4 is 6. So our target we achieved at the first iteration and the first point only. So simply 0 0 and 1. So its position is going to get returned, which is 1 and 3. I'll quickly code this solution. Our left we are I'm going to do it in JavaScript only. Left is going to be 0. We will assume that we are going to start from leftmost and rightmost index only all the time. Numbers is the array, and I'm going to compute its length. And simply copy this. This is the same thing what we have done. Remove this. Left, right, if array of left, okay. And we know that we are going to find the solution, so we don't have to worry about what if we don't find anything in the loop and we don't come across any solution, because it is already given that exactly one solution exists. I'll try to run this. Okay, so this is accepted. I'll submit. So this is solved. I hope I'll try to add and also try to give you the I'll give you the homework that please do solve binary search problem as well, because this is similar to what because this is going to be a very similar problem only. You just have to do one thing different, that you have to compute middle at every index. Okay, thank you.